1. The design of the following treatise is to investigate the fundamental laws of those operations of the mind by which reasoning is performed, to give expression to them in the symbolical language of a calculus, and upon this foundation to establish the science of logic and construct its method, to make that method itself the basis of a general method for the application of the mathematical doctrine of probabilities, and, finally, to collect from the various elements of truth brought to view in the course of these inquiries some probable intimations concerning the nature and constitution of the human mind. 2. That this design is not altogether a novel one, it is almost needless to remark, and it is well known that to its two main practical divisions of logic and probabilities a very considerable share of the attention of philosophers has been directed. In its ancient and scholastic form, indeed, the subject of logic stands almost exclusively associated with the great name of Aristotle. As it was presented to ancient Greece in the party technical, partly metaphysical disquisitions of the organon, such with scarcely any essential change, it has continued to the present day. The stream of original inquiry has rather been directed towards questions of general philosophy, which, though they have arisen among the disputes of the logicians, have outgrown their origin, and given to successive ages of speculation their peculiar bent and character. The eras of Porphyry and Proclus, of Anselm and Abelard, of Ramus and of Descartes, together with the final protests of Bacon and Locke, rise up before the mind as examples of the remoter influences of the study upon the course of human thought, partly in suggesting topics fertile of discussion, partly in provoking remonstrance against its own undue pretensions. The history of the theory of probabilities, on the other hand, has presented far more of that character of steady growth which belongs to science. In its origin, the early genius of Pascal, in its maturer stages of development the most recondite of all the mathematical speculations of Laplace, were directed to its improvement. To omit here the mention of other names scarcely less distinguished than these. As the study of logic has been remarkable for the kindred questions of metaphysics to which it has given occasion, so that of probabilities also has been remarkable for the impulse which it has bestowed upon the higher departments of mathematical science. Each of these subjects has, moreover, been justly regarded as having relation to a speculative as well as to a practical end. To enable us to deduce correct inferences from given premises is not the only object of logic, nor is it the sole claim of the theory of probabilities that it teaches us how to establish the business of life assurance on a secure basis, and how to condense whatever is valuable in the records of innumerable observations in astronomy, in physics, or in that field of social inquiry, which is fast assuming a character of great importance. Both these studies have also an interest of another kind, derived from the light which they shed upon the intellectual powers. They instruct us concerning the mode in which language and number serve as instrumental aids to the processes of reasoning. They reveal to us in some degree the connection between different powers of our common intellect. They set before us what, in the two domains of demonstrative and of probable knowledge, are the essential standards of truth and correctness. Standards not derived from without, but deeply founded in the constitution of the human faculties. These ends of speculation yield neither in interest nor in dignity, nor yet, it may be added, in importance, to the practical objects with the pursuit of which they have been historically associated. To unfold the secret laws and relations of those high faculties of thought by which all beyond the merely perspective knowledge of the world and of ourselves is attained or matured, is an object which does not stand in need of commendation to a rational mind. 3. But although certain parts of the design of this work have been entertained by others, its general conception, its method, and, to a considerable extent, its results, are believed to be original. For this reason I shall offer, in the present chapter, some preparatory statements and explanations in order that the real aim of this treatise may be understood, and the treatment of its subject facilitated. 4. Like all other sciences, that of the intellectual operations must primarily rest upon observation, the subject of such observation being the very operations and processes of which we desire to determine the laws. But while the necessity of a foundation in experience is thus a condition common to all sciences, there are some special differences between the modes in which the principle becomes available for the determination of general truths when the subject of inquiry is the mind, and when the subject is external nature. To these it is necessary to direct attention. The general laws of nature are not, for the most part, immediate objects of perception. They are either inductive inferences from a large body of facts, the common truth in which they express, or, in their original at least, physical hypothesis of a causal nature, serving to explain phenomena with undeviating precision, and to enable us to predict new combinations of them. They are, in all cases, and in the strictest sense of the term, probable conclusions, approaching, indeed, ever and ever nearer to certainty, as they receive more and more of the confirmation of experience. But of the character of probability, in the strict and proper sense of that term, they are never wholly divested. On the other hand, the knowledge of the laws of the mind does not require as its basis any extensive collection of observations. The general truth is seen in the particular instance, and it is not confirmed by the repetition of instances. We may illustrate this position by an obvious example. It may be a question whether that formula of reasoning which is called the dictum of Aristotle, de omni et nullo, expresses a primary law of human reasoning or not. But it is no question that it expresses a general truth in logic. Now that truth is made manifest in all its generality by reflection upon a single instance of its application. And this is both an evidence that the particular principle or formula in question is founded upon some general law, or laws of the mind, and an illustration of the doctrine that the perception of such general truths is not derived from an induction from many instances, but is involved in the clear apprehension of a single instance. In connection with this truth is seen the not less important one, that our knowledge of the laws upon which the science of the intellectual powers rests, whatever may be its extent or its deficiency, is not probable knowledge. For we not only see in the particular example the general truth, but we see it also as a certain truth, a truth, our confidence in which will not continue to increase with increasing experience of its practical verifications. 5. But if the general truths of logic are of such a nature that when presented to the mind they at once command assent, wherein consists the difficulty of constructing the science of logic? Not, it may be answered, in collecting the materials of knowledge, but in discriminating their nature and determining their mutual place and relation. All sciences consist of general truths, but of those truths, some only are primary and fundamental, others are secondary and derived. The laws of elliptic motion, discovered by Kepler, are general truths in astronomy, but they are not its fundamental truths. And it is also in the purely mathematical sciences. An almost boundless diversity of theorems which are known, and an infinite possibility of others, as yet unknown, rest together upon the foundation of a few simple axioms, and yet these are all general truths. It may be added that they are truths which to an intelligence sufficiently refined would shine forth in their own unborrowed light, without the need of those connecting links of thought, those steps of wearisome and often painful deduction by which the knowledge of them is actually acquired. Let us define as fundamental those laws and principles from which all other general truths of science may be deduced, and into which they may all again be resolved. Shall we then err in regarding that as the true science of logic which, laying down certain elementary laws, confirmed by the very testimony of the mind, permits us thence to deduce, by uniform processes, the entire chain of its secondary consequences, and furnishes, for its practical applications, methods of perfect generality? Let it be considered whether in any science, viewed either as a system of truth or as the foundation of a practical art, there can properly be any other test of the completeness and the fundamental character of its laws than the completeness of its system of derived truths, and the generality of the methods which it serves to establish. Other questions may indeed present themselves. Convenience, prescription, individual preference may urge their claims and deserve attention, but as respects the question of what constitutes science in its abstract integrity, I apprehend that no other considerations than the above are properly of any value. 6. It is designed in the next place to give expression in this treatise to the fundamental laws of reasoning in the symbolical language of a calculus. Upon this head, it will suffice to say that those laws are such as to suggest this mode of expression, and to give to it a peculiar and exclusive fitness for the ends in view. There is not only a close analogy between the operations of the mind in general reasoning and its operations in the particular science of algebra, but there is, to a considerable extent, an exact agreement in the laws by which the two classes of operations are conducted. Of course, the laws must in both cases be determined independently. Any formal agreement between them can only be established a posteriori by actual comparison. To borrow the notation of the science of number, and then assume that in its new application the laws by which its use is governed will remain unchanged, would be mere hypothesis. There exist, indeed, certain general principles founded in the very nature of language, by which the use of symbols, which are but the elements of scientific language, is determined. To a certain extent, these elements are arbitrary. Their interpretation is purely conventional. We are permitted to employ them in whatever sense we please, but this permission is limited by two indispensable conditions. First, that from the sense once conventionally established, we never, in the same process of reasoning, depart. Secondly, that the laws by which the process is conducted be founded exclusively upon the above fixed sense or meaning of the symbols employed. In accordance with these principles, any agreement which may be established between the laws of the symbols of logic and those of algebra can but issue in an agreement of processes. The two provinces of interpretation remain apart and independent, each subject to its own laws and conditions. Now the actual investigations of the following pages exhibit logic, in its practical aspect, as a system of processes carried on by the aid of symbols having a definite interpretation, and subject to laws founded upon that interpretation alone. But at the same time, they exhibit those laws as identical in form with the laws of the general symbols of algebra, with this single addition, that the symbols of logic are further subject to a special law, Chapter 2, to which the symbols of quantity, as such, are not subject. Upon the nature and the evidence of this law it is not purposed here to dwell. These questions will be fully discussed in a future page. But as constituting the essential ground of difference between those forms of inference with which logic is conversant, and those which present themselves in the particular science of number, the law in question is deserving of more than a passing notice. It may be said that it lies at the very foundation of general reasoning, that it governs those intellectual acts of conception or of imagination, which are preliminary to the processes of logical deduction, and that it gives to the processes themselves much of their actual form and expression. It may hence be affirmed that this law constitutes the germ or seminal principle, of which every approximation to a general method in logic is the more or less perfect development. The principle has already been laid down that the sufficiency and truly fundamental character of any assumed system of laws in the science of logic must partly be seen in the perfection of the methods to which they conduct us. It remains, then, to consider what the requirements of a general method in logic are, and how far they are fulfilled in the system of the present work. Logic is conversant with two kinds of relations among things and relations among facts. But as facts are expressed by propositions, the latter species of relation may, at least for the purposes of logic, be resolved into a relation among propositions. The assertions that the fact or event A is an invariable consequent of the fact or event B may, to this extent at least, be regarded as equivalent to the assertion that the truth of the proposition affirming the occurrence of the event B always implies the truth of the proposition affirming the occurrence of the event A. Instead, then, of saying that logic is conversant with relations among things and relations among facts, we are permitted to say that it is concerned with relations among things and relations among propositions. Of the former kind of relations, we have an example in the proposition, "All men are mortal." Of the latter kind, in this proposition, "If the sun is totally eclipsed, the stars will become visible." The one expresses a relation between men and mortal beings, the other between the elementary propositions, "The sun is totally eclipsed. The stars will become visible." Among such relations I suppose to be included those which affirm or deny existence with respect to things, and those which affirm or deny truth with respect to propositions. Now, let those things or those propositions among which relation is expressed be termed the elements of the propositions by which such relation is expressed. Proceeding from this definition, we may then say that the premises of any logical argument express given relations among certain elements, and that the conclusion must express an implied relation among those elements, or among a part of them, i.e., a relation implied by, or inferentially involved in the premises. 8. Now, this being premised, the requirements of a general method in logic seem to be the following. First, as the conclusion must express a relation among the whole or among a part of the elements involved in the premises, it is requisite that we should possess the means of eliminating those elements which we desire not to appear in the conclusion, and of determining the whole amount of relation implied by the premises among the elements which we wish to retain. Those elements which do not present themselves in the conclusion are, in the language of the common logic, called middle terms, and the species of elimination, exemplified in treatises on logic, consists in deducing from two propositions, containing a common element or middle term, a conclusion connecting the two remaining terms. But the problem of elimination, as contemplated in this work, possesses a much wider scope. It proposes not merely the elimination of one middle term from two propositions, but the elimination generally of middle terms from propositions, without regard to the number of either of them, or to the nature of their connection. To this object, neither the processes of logic nor those of algebra, in their actual state, present any strict parallel. In the latter science, the problem of elimination is known to be limited in the following manner. From two equations, we can eliminate one symbol of quantity, from three equations, two symbols, and generally from n equations n minus 1 symbols. But though this condition necessary in algebra seems to prevail in the existing logic also, it has no essential place in logic as a science. There, no relation whatever can be proved to prevail between the number of terms to be eliminated and the number of propositions from which the elimination is to be effected. From the equation representing a single proposition, any number of symbols representing terms or elements in logic may be eliminated, and from any number of equations representing propositions, one or any other number of symbols of this kind may be eliminated in a similar manner. For such elimination, there exists one general process applicable to all cases. This is one of the many remarkable consequences of that distinguishing law of the symbols of logic, to which attention has been already directed. Secondly, it should be within the province of a general method in logic to express the final relation among the elements of the conclusion by any admissible kind of proposition, or in any selected order of terms. Among varieties of kind, we may reckon those which logicians have designated by the terms categorical, hypothetical, disjunctive, etc. To a choice or selection in the order of the terms, we may refer whatsoever is dependent upon the appearance of particular elements in the subject or in the predicate, in the antecedent or in the consequent of that proposition which forms the conclusion. But waiving the language of the schools, let us consider what really distinct species of problems may present themselves to our notice. We have seen that the elements of the final or inferred relation may either be things or propositions. Suppose the former case, then it might be required to deduce from the premises a definition or description of some one thing, or class of things, constituting an element of the conclusion in terms of the other things involved in it. Or we might form the conception of some thing or class of things, involving more than one of the elements of the conclusion, and require its expression in terms of the other elements. Again, suppose the elements retained in the conclusion to be propositions. We might desire to ascertain such points as the following, viz., whether in virtue of the premises, any of those propositions taken singly are true or false, whether particular combinations of them are true or false, whether assuming a particular proposition to be true, any consequences will follow, and if so, what consequences with respect to the other propositions, whether any particular condition being assumed with reference to certain of the propositions, any consequences and what consequences will follow with respect to the others, and so on. I say that these are general questions, which it should fall within the scope or province of a general method in logic to solve. Perhaps we might include them all under this one statement of the final problem of practical logic. Given a set of premises expressing relations among certain elements, whether things or propositions, required explicitly the whole relation consequent among any of those elements under any proposed conditions, and in any proposed form. That this problem, under all its aspects, is resolvable, will hereafter appear. But it is not for the sake of noticing this fact that the above inquiry into the nature and the functions of a general method in logic has been introduced. It is necessary that the reader should apprehend what are the specific ends of the investigation upon which we are entering, as well as the principles which are to guide us to the attainment of them. 9. Possibly, it may here be said that the logic of Aristotle, in its rules of syllogism and conversion, sets forth the elementary processes of which all reasoning consists, and that beyond these there is neither scope nor occasion for a general method. I have no desire to point out the defects of the common logic, nor do I wish to refer to it any further than is necessary, in order to place in its true light the nature of the present treatise. With this end alone in view, I would remark, first, that syllogism, conversion, are not the ultimate processes of logic. It will be shown in this treatise that they are founded upon and are resolvable into ulterior and more simple processes which constitute the real elements of method in logic. Nor is it true in fact that all inference is reducible to the particular forms of syllogism and conversion. Secondly, if all inference were reducible to these two processes, and it has been maintained that it is reducible to syllogism alone, there would still exist the same necessity for a general method. For it would still be requisite to determine in what order the processes should succeed each other, as well as their particular nature, in order that the desired relation should be obtained. By the desired relation, I mean that full relation, which, in virtue of the premises, connects any element selected out of the premises at will, and which, moreover, expresses that relation in any desired form and order. If we may judge from the mathematical sciences, which are the most perfect examples of method known, this directive function of method constitutes its chief office and distinction. The fundamental processes of arithmetic, for instance, are in themselves but the elements of a possible science. To assign their nature is the first business of its method, but to arrange their succession is its subsequent and higher function. In the more complex examples of logical deduction, and especially in those which form a basis for the solution of difficult questions, in the theory of probabilities, the aid of a directive method, such as calculus alone can supply, is indispensable. 10. Whence it is that the ultimate laws of logic are mathematical in their form, why they are, except in a single point, identical with the general laws of number, and why in that particular point they differ, are questions upon which it might not be very remote, from presumption, to endeavour to pronounce a positive judgment. Probably, they lie beyond the reach of our limited faculties. It may perhaps be permitted to the mind to attain a knowledge of the laws to which it is itself subject, without its being also given to it to understand their ground and origin, or even, except in a very limited degree, to comprehend their fitness for their end, as compared with other and conceivable systems of law. Such knowledge is, indeed, unnecessary for the ends of science, which properly concerns itself with what is, and seeks not for grounds of preference or reasons of appointment. These considerations furnish a sufficient answer to all protests against the exhibition of logic in the form of a calculus. It is not because we choose to assign to it such a mode of manifestation, but because the ultimate laws of thought render that mode possible, and prescribe its character and forbid, as it would seem, the perfect manifestation of the science in any other form, that such a mode demands adoption. It is to be remembered that it is the business of science not to create laws, but to discover them. We do not originate the constitution of our own minds, greatly as it may be in our power to modify their character. And as the laws of the human intellect do not depend upon our will, so the forms of the science, of which they constitute the basis, are in all essential regards independent of individual choice. 11. Beside the general statement of the principles of the above method, this treatise will exhibit its application to the analysis of a considerable variety of propositions, and of trains of propositions constituting the premises of demonstrative arguments. These examples have been selected from various writers. They differ greatly in complexity, and they embrace a wide range of subjects, though in this particular respect it may appear to some that too great a latitude of choice has been exercised. I do not deem it necessary to offer any apology upon this account. That logic, as a science, is susceptible of very wide applications is admitted, but it is equally certain that its ultimate forms and processes are mathematical. Any objection a priori, which may therefore be supposed to lie against the adoption of such forms and processes in the discussion of a problem of morals or of general philosophy, must be founded upon misapprehension or false analogy. It is not of the essence of mathematics to be conversant with the ideas of number and quantity. Whether as a general habit of mind, it would be desirable to apply symbolical processes to moral argument, is another question. Possibly, as I have elsewhere observed, the perfection of the method of logic may be chiefly valuable as an evidence of the speculative truth of its principles. To supersede the employment of common reasoning, or to subject it to the rigour of technical forms, would be the last desire of one who knows the value of that intellectual toil and warfare which imparts to the mind an athletic vigour, and teaches it to contend with difficulties, and to rely upon itself in emergencies. Nevertheless, cases may arise in which the value of a scientific procedure, even in those things which fall confessedly under the ordinary dominion of the reason, may be felt and acknowledged. Some examples of this kind will be found in the present work. 12. The general doctrine and method of logic above explained form also the basis of a theory and corresponding method of probabilities. Accordingly, the development of such a theory and method, upon the above principles, will constitute a distinct object of the present treatise. Of the nature of this application, it may be desirable to give here some account, more especially as regards the character of the solutions to which it leads. In connection with this object, some further detail will be requisite concerning the forms in which the results of the logical analysis are presented. The ground of this necessity of a prior method in logic, as the basis of a theory of probabilities, may be stated in a few words. Before we can determine the mode in which the expected frequency of occurrence of a particular event is dependent upon the known frequency of occurrence of any other events, we must be acquainted with the mutual dependence of the events themselves. Speaking technically, we must be able to express the event whose probability is sought as a function of the events whose probabilities are given. Now, this explicit determination belongs in all instances to the department of logic. Probability, however, in its mathematical acceptation, admits of numerical measurement. Hence the subject of probabilities belongs equally to the science of number and to that of logic. In recognizing the coordinate existence of both these elements, the present treatise differs from all previous ones. And as this difference not only affects the question of the possibility of the solution of problems in a large number of instances, but also introduces new and important elements into the solutions obtained, I deem it necessary to state here, at some length, the peculiar consequences of the theory developed in the following pages. 13. The measure of the probability of an event is usually defined as a fraction, of which the numerator represents the number of cases favourable to the event, and the denominator the whole number of cases favourable and unfavourable, all cases being supposedly equally likely to happen. That definition is adopted in the present work. At the same time, it is shown that there is another aspect of the subject, shortly to be referred to, which might equally be regarded as fundamental, and which would actually lead to the same system of methods and conclusions. It may be added that so far as the received conclusions of the theory of probabilities extend, and so far as they are consequences of its fundamental definitions, they do not differ from the results, supposed to be equally correct in inference, of the method of this work. Again, although questions in the theory of probabilities present themselves under various aspects, and may be variously modified by algebraical and other conditions, there seems to be one general type to which all such questions, or so much of each of them as truly belongs to the theory of probabilities, may be referred. Considered with reference to the data and the quisitum, that type may be described as follows. First, the data are the probabilities of one or more given events, each probability being either that of the absolute fulfillment of the event to which it relates, or the probability of its fulfillment under given supposed conditions. Secondly, the quaesitum, or object sought, is the probability of the fulfillment, absolutely or conditionally, of some other event differing in expression from those in the data, but more or less involving the same elements. As concerns the data, they are either causally given, as when the probability of a particular throw of a die is deduced from a knowledge of the constitution of the piece, or they are derived from observation of repeated instances of the success or failure of events. In the latter case, the probability of an event may be defined as the limit toward which the ratio of the favourable to the whole number of observed cases approaches, the uniformity of nature being presupposed, as the observations are indefinitely continued. Lastly, as concerns the nature or relation of the events in question, an important distinction remains. Those events are either simple or compound. By a compound event is meant one of which the expression in language or the conception in thought depends upon the expression or the conception of other events, which, in relation to it, may be regarded as simple events. To say it rains, or to say it thunders, is to express the occurrence of a simple event. But to say it rains and thunders, or to say it either rains or thunders, is to express that of a compound event. For the expression of that event depends upon the elementary expressions, it rains, it thunders. The criterion of simple events is not, therefore, any supposed simplicity in their nature. It is founded solely on the mode of their expression in language or conception in thought. 14. Now, one general problem which the existing theory of probabilities enables us to solve is the following. Given the probabilities of any simple events, required the probability of a given compound event, i.e., of an event compounded in a given manner, out of the given simple events. The problem can also be solved when the compound event, whose probability is required, is subjected to given conditions, i.e., to conditions dependent also in a given man, on the given simple events. Beside this general problem, there exist also particular problems of which the principle of solution is known. Various questions relating to causes and effects can be solved by known methods under the particular hypothesis that the causes are mutually exclusive, but apparently not otherwise. Beyond this, it is not clear that any advance has been made toward the solution of what may be regarded as the general problem of the science. Given the probabilities of any events, simple or compound, conditioned or unconditioned, required the probability of any other event equally arbitrary in expression and conception. In the statement of this question, it is not even postulated that the events whose probabilities are given and the one whose probability is sought should involve some common elements, because it is the office of a method to determine whether the data of a problem are sufficient for the end in view, and to indicate, when they are not so, wherein the deficiency consists. This problem, in the most unrestricted form of its statement, is resolvable by the method of the present treatise, or, to speak more precisely, its theoretical solution is completely given, and its practical solution is brought to depend only upon processes purely mathematical, such as the resolution and analysis of equations. The order and character of the general solution may be thus described. 15. In the first place, it is always possible, by the preliminary method of the calculus of logic, to express the event whose probability is sought as a logical function of the events whose probabilities are given. The result is of the following character. Suppose that x represents the event whose probability is sought, a, b, c, etc., the events whose probabilities are given, those events being either simple or compound. Then, the whole relation of the event x to the events a, b, c, etc., is deduced in the form of what mathematicians term a development, consisting, in the most general case, of 4 distinct classes of terms. By the first class are expressed those combinations of the events A, B, C which both necessarily accompany and necessarily indicate the occurrence of the event X. By the second class, those combinations which necessarily accompany but do not necessarily imply the occurrence of the event X. By the third class, those combinations whose occurrence in connection with the event X is impossible, but not otherwise impossible. By the fourth class, those combinations whose occurrence is impossible under any circumstances. I shall not dwell upon this statement of the result of the logical analysis of the problem, further than to remark that the elements which it presents are precisely those by which the expectation of the event X, as dependent upon our knowledge of the events ABC, is, or alone can be, affected. General reasoning would verify this conclusion, but general reasoning would not usually avail to disentangle the complicated web events and circumstances from which the solution above described must be evolved. The attainment of this object constitutes the first step towards the complete solution of the question I proposed. It is to be noted that thus far the process of solution is logical, i.e. conducted by symbols of logical significance and resulting in an equation interpretable into a proposition. Let this result be termed the final logical equation. The second step of the process deserves attentive remark. From the final logical equation to which the previous step has conducted us are deduced by inspection a series of algebraic equations implicitly involving the complete solution of the problem proposed. Of the mode in which this transition is effected, let it suffice to say that there exists a definite relation between the laws by which the probabilities of events are expressed as algebraic functions of the probabilities of other events upon which they depend, and the laws by which the logical connection of the events is itself expressed. This relation, like the other coincidences of formal law which have been referred to, is not founded upon hypothesis, but is made known to us by observation and reflection. If, however, its reality were assumed a priori as the basis of the very definition of probability, strict deduction would thence lead us to the received numerical definition as a necessary consequence. The theory of probabilities stands, as it has already been remarked, in equally close relation to logic and to arithmetic, and it is indifferent, so far as results are concerned, whether we regard it as springing out of the latter of these sciences, or as founded in the mutual relations which connect the two together. 16. There are some circumstances, interesting perhaps to the mathematician, attending the general solutions deduced by the above method, which it may be desirable to notice. First, as the method is independent of the number and the nature of the data, it continues to be applicable when the latter are insufficient to render determinate the value sought. When such is the case, the final expression of the solution will contain terms with arbitrary constant coefficients. To such terms, there will correspond terms in the final logical equation, the interpretation of which will inform us what new data are requisite in order to determine the values of those constants, and thus render the numerical solution complete. If such data are not to be obtained, we can still, by giving to the constants their limiting values 0 and 1, determine the limits within which the probability sought must lie independently of all further experience. When the event whose probability is sought is quite independent of those whose probabilities are given, the limits thus obtained for its value will be 0 and 1, as it is evident that they ought to be, and the interpretation of the constants will only lead to a restatement of the original problem. Secondly, the expression of the final solution will in all cases involve a particular element of quantity, determinable by the solution of an algebraic equation. Now, when that equation is of an elevated degree, a difficulty may seem to arise as to the selection of the proper route. There are, indeed, cases in which both the elements given and the elements sought are so obviously restricted by necessary conditions that no choice remains. But in complex instances, the discovery of such conditions by unassisted force of reasoning would be hopeless. A distinct method is requisite for this end. A method which might not appropriately be termed the calculus of statistical conditions. Into the nature of this method I shall not here further enter than to say that, like the previous method, it is based upon the employment of the final logical equation, and that it definitely assigns, first, the conditions which must be fulfilled among the numerical elements of the data, in order that the problem may be real, i.e., derived from a possible experience. Secondly, the numerical limits within which the probability sought must have been confined if, instead of being determined by theory, it had been deduced directly by observation from the same system of phenomena from which the data were derived. It is clear that these limits will be actual limits of the probability sought. Now, on supposing the data subject to the conditions above assigned to them, it appears in every instance which I have examined that there exists one root, and only one root, of the final algebraic equation, which is subject to the required limitations. Every source of ambiguity is thus removed. It would even seem that new truths relating to the theory of algebraic equations are thus incidentally brought to light. It is remarkable that the special element of quantity to which the previous discussion relates depends only upon the data, and not at all upon the quositum of the problem proposed. Hence, the solution of each particular problem unties the knot of difficulty for a system of problems, for that system of problems which is marked by the possession of common data, independently of the nature of their quosita. This circumstance is important whenever from a particular system of data it is required to deduce a series of connected conclusions, and it further gives to the solutions of particular problems that character of relationship derived from their dependence upon a central and fundamental unity, which not unfrequently marks the application of general methods. 17. But though the above considerations, which others of a like nature, justify the assertion that the method of this treatise for the solution of questions in the theory of probabilities is a general method, it does not thence follow that we are relieved in all cases from the necessity of recourse to hypothetical grounds. It has been observed that a solution may consist entirely of terms affected by arbitrary constant coefficients, may, in fact, be wholly indefinite. The application of the method of this work to some of the most important questions within its range would, were the data of experience alone employed, present results of this character. To obtain a definite solution, it is necessary in such cases to have recourse to hypotheses possessing more or less of independent probability but incapable of exact verification. Generally speaking, such hypotheses will differ from the immediate results of experience in partaking of a logical rather than of a numerical character, in prescribing the conditions under which phenomena occur, rather than assigning the relative frequency of their occurrence. This circumstance is, however, unimportant. Whatever their nature may be, the hypothesis assumed must thenceforth be regarded as belonging to the actual data, although tending, as is obvious, to give to the solution itself somewhat of a hypothetical character. With this understanding as to the possible sources of the data actually employed, the method is perfectly general. But for the correctness of the hypothetical elements introduced, it is of course no more responsible than for the correctness of the numerical data derived from experience. In illustration of these remarks, we may observe that the theory of the reduction of astronomical observations rests, in part, upon hypothetical grounds. It assumes certain positions as to the nature of error, the equal probabilities of its occurrence in the form of excess or defect, without which it would be impossible to obtain any definite conclusions from a system of conflicting observations. But granting such positions as the above, the residue of the investigation falls strictly within the province of the theory of probabilities. Similar observations apply to the important problem which proposes to deduce from the records of the majorities of a deliberative assembly the mean probability of correct judgment in one of its members. If the method of this treatise be applied to the mere numerical data, the solution obtained is of that wholly indefinite kind above described. And to show in a more eminent degree the insufficiency of those data by themselves, the interpretation of the arbitrary constants which appear in the solution merely produces a restatement of the original problem. Admitting, however, the hypothesis of the independent formation of opinion in the individual mind, either absolutely, as in the speculations of Laplace and Poisson, or under limitations imposed by the actual data, as will be seen in this treatise, the problem assumes a far more definite character. It will be manifest that the ulterior value of the theory of probabilities must depend very much upon the correct formation of such mediate hypothesis, where the purely experimental data are insufficient for definite solution, and where that further experience indicated by the interpretation of the final logical equation is unattainable. Upon the other hand, an undue readiness to form hypotheses in subjects which, from their very nature, are placed beyond human ken, must react upon the credit of the theory of probabilities and tend to throw doubt in the general mind over its most legitimate conclusions. 18. It would perhaps be premature to speculate here upon the question whether the methods of abstract science are likely, at any future day, to render service in the investigation of social problems, at all commensurate with those which they have rendered in various departments of physical inquiry. An attempt to resolve this question upon pure a priori grounds of reasoning would be very likely to mislead us. For example, the consideration of human free agency would seem at first sight to preclude the idea that the movements of the social system should ever manifest that character of orderly evolution, which we are prepared to expect under the reign of a physical necessity. Yet, already do the researches of the statist reveal to us facts at variance with such an anticipation. Thus the records of crime and pauperism present a degree of regularity unknown in regions in which the disturbing influence of human wants and passions is unfelt. On the other hand, the distemperature of seasons, the eruption of volcanoes, the spread of blight in the vegetable, or of epidemic maladies in the animal kingdom, things apparently or chiefly the product of natural causes, refuse to be submitted to regular and apprehensible laws. Fickle as the wind is a proverbial expression. Reflection upon these points teaches us in some degree to correct our earlier judgments. We learn that we are not to expect, under the dominion of necessity, an order perceptible to human observation, unless the play of its producing causes is sufficiently simple, nor, on the other hand, to deem that free agency in the individual is inconsistent with regularity in the motions of the system of which he forms a component unit. Human freedom stands out as an apparent fact of our consciousness, while it is also, I conceive, a highly probable deduction of analogy, from the nature of that portion of the mind whose scientific constitution we are able to investigate. But whether accepted as a fact, reposing on consciousness, or as a conclusion sanctioned by the reason, it must be so interpreted as not to conflict with an established result of observation. That phenomena in the production of which large masses of men are concerned, do actually exhibit a very remarkable degree of regularity, enabling us to collect in each succeeding age the elements upon which the estimate of its state and progress, so far as manifested in outward results, must depend. There is thus no sound objection, a priori, against the possibility of that species of data which is requisite for the experimental foundation of a science of social statistics. Again, whatever other object this treatise may accomplish, it is presumed that it will leave no doubt as to the existence of a system of abstract principles, and of methods founded upon those principles, by which any collective body of social data may be made to yield, in an explicit form, whatever information they implicitly involve. There may, where the data are exceedingly complex, be very great difficulty in obtaining this information, difficulty due not to any imperfection of the theory, but to the laborious character of the analytical processes to which it points. It is quite conceivable that in many instances that difficulty may be such as only united effort could overcome, but that we possess theoretically in all cases, and practically, so far as the requisite labour of calculation may be supplied, the means of evolving from statistical records the seeds of general truths which lie buried amid the mass of figures, is a position which may, I conceive, with perfect safety, be affirmed. 19. But beyond these general positions, I do not venture to speak in terms of assurance. Whether the results which might be expected from the application of scientific methods to statistical records, over and above those, the discovery of which requires no such aid, would so far compensate for the labour involved as to render it worth while to institute such investigations upon a proper scale of magnitude, is a point which could, perhaps, only be determined by experience. It is to be desired, and it might without great presumption be expected, that in this, as in other instances, the abstract doctrines of science should minister to more than intellectual gratification, nor, viewing the apparent order in which the sciences have been evolved, and have successfully contributed their aid to the service of mankind, does it seem very improbable that a day may arrive in which similar aid may accrue from departments of the field of knowledge, yet more intimately allied with the elements of human welfare. Let the speculations of this treatise, however, rest at present simply upon their claim to be regarded as true. 20. I design, in the last place, to endeavour to educe from the scientific results of the previous inquiries some general intimations respecting the nature and constitution of the human mind. Into the grounds of the possibility of this species of inference it is not necessary to enter here. One or two general observations may serve to indicate the track which I shall endeavour to follow. It cannot but be admitted that our views of the science of logic must materially influence, perhaps mainly determine, our opinions upon the nature of the intellectual faculties. For example, the question whether reasoning consists merely in the application of certain first or necessary truths, with which the mind has been originally imprinted, or whether the mind itself a seat of law, whose operation is as manifest and as conclusive in the particular as in the general formula, or whether, as some not undistinguished writers seem to maintain, all reasoning is of particulars. This question, I say, is one which not merely affects the science of logic, but also concerns the formation of just views of the constitution of the intellectual faculties. Again, if it is concluded that the mind is by original constitution a seat of law, the question of the nature of its subjection to this law, whether, for instance, it is an obedience founded upon necessity, like that which sustains the revolutions of the heavens and preserves the order of nature, or whether it is a subjection of some quite distinct kind, is also a matter of deep speculative interest. Further, if the mind is truly determined to be a subject of law, and if its laws also are truly assigned, the question of their probable or necessary influence upon the course of human thought in different ages is one invested with great importance, and well deserving a patient investigation, as matter both of philosophy and of history. These and other questions I propose, however imperfectly, to discuss in the concluding portion of the present work. They belong perhaps to the domain of probable or conjectural rather than to that of positive knowledge. But it may happen that where there is not sufficient warrant for the certainties of science, there may be grounds of analogy adequate for the suggestion of highly probable opinions. It has seemed to me better than this discussion should be entirely reserved for the sequel of the main business of this treatise, which is the investigation of scientific truths and laws. Experience sufficiently instructs us that the proper order of advancement in all inquiries after truth is to proceed from the known to the unknown. There are parts, even of the philosophy and constitution of the human mind, which have been placed fully within the reach of our investigation. To make a due acquaintance with those portions of our nature, the basis of all endeavours to penetrate amid the shadows and uncertainties of that conjectural realm which lies beyond and above them, is the course most accordant with the limitations of our present condition. This has been And or Not, a glimpse of the logical mind of George Boole, written by George Boole, narrated by Ian Kingsley. Copyright 2019 by David C. Lane. Production copyright by David C. Lane.
Audible hopes you have enjoyed this program.